Okay, so the last thing that we want to be able to do with radians is identify the positive and negative coterminal angles. Now, when we did this with angles, when we did this with the angles in degrees, we added and subtracted 360, which is one entire revolution. But in radians, 360 degrees is exactly the same thing as 2 pi, right? So we can see here that instead of 360 degrees, it is replaced with 2 pi, which is equivalent to 360 degrees. So the first thing we want to be able to do is we want to be able to graph 2 pi over 3. So let's go to our xy axis over here, and we're going to graph 2 pi over 3. We always start on the initial side. Then we are going to travel 2 pi over 3. So remember, we're looking at the fractions, 2 over 3. 2 over 3 is bigger than 1/2, but not quite as big as 1. So I know that I'm somewhere inside of the second quadrant. All right, so here's my first. I know I end up somewhere in the second quadrant. And go ahead and label the rest of the quadrants. Okay, so now what I want to do is I want to find a coterminal. I'm going to first look for the negative coterminal angle. So I'm going to start with this negative one right here, and I'm going to travel clockwise until I end up here at this terminal side. So if we notice that just like with degrees, we notice that the difference between two coterminal angles is exactly one full circle. So in degrees, one full revolution is 360. In radians, one full revolution is 2 pi. So that's where that 2 pi comes from. So we're going to go ahead and we're going to now find that angle in the red, that coterminal angle, using 2 pi over 3. If we want to find the negative, I'm going to have to subtract one revolution. I'm going to subtract 2 pi. So I need to get common denominators here. So I'm going to multiply the top and the bottom by 3. And then I'm going to end up with 2 pi over 3 minus, and then 2 pi over 1 is now going to become 6 pi over 3. And then I'm just going to simplify the top. 2 minus 6 is just negative 4 pi, and the denominator stays as 3. And that's our first coterminal angle. So now we know that this angle in the red over here, so this, we'll call this theta prime, right? Some other angle is now equal to negative 4 pi over 3. And that makes sense because negative 4 over 3, we know that that is going to be bigger, that's bigger than negative 1/2, bigger than negative 1, but not quite as big as negative 3 over 2. So it's got to be somewhere in that second quadrant. All right, now let's look for the positive coterminal angle. So we're going to want to start at the initial side. So I start right here at 0, but now I'm going to want to travel counterclockwise, but now I want to go past my angle, go all the way around, and then I'm going to end up at that exact same terminal side. So it is a coterminal angle, but now in order for us to find the measurement of this is I'm going to go one full revolution around, which is 2 pi, and then I'm going to add that to just the measurement of that angle. Right, so we can see that the angle highlighted in the light blue is one full revolution. So in this case it's 2 pi, and then plus I'm adding that angle. So what I have to do is I'm going to have to do that exact same thing algebraically. So I'm going to take 2 pi over 3, and now I'm going to have to add one full revolution to it, 2 pi. So let's get our denominator of 1. We're going to multiply the top and the bottom by 3. So now we end up with 2 pi over 3 plus, this is going to become 6 pi over 3. And then now I'm just going to go ahead and add them up. So 2 plus 6 is 8 pi, and then over 3. And there we go. Those are our two coterminal angles.